Here's an interesting question where you need to express these two logarithms as a single logarithm. Sort of a trickier kind of question. So, to proceed, one of the things that bothers me right away is this term out front. So it's question 51. Sorry, and this is in section 5.4 in our great text. So these factors out front, to combine these logarithms, like the rule is ln of, say, 5 minus ln of 6. If I have that, I can write it as ln of 5 divided by 6, quotient rule. But there's nothing out front in the rule here. So I need to use the power rule and get these, the 3/2, back into part of this term inside of the logarithm. So that you can use the power rule. So this first one will become ln, and then it'll be this whole thing that I was taking the logarithm of, the 4x to the 6th, raised to the 3/2 power. It's important to make sure you raise the whole thing to that 3/2. Okay, minus, then this other one similarly will go ln of 2y to the 10th, all to the 4/5. Okay, so now that I have ln of something minus ln of something, I can use my quotient rule over here. So I can say this is the same thing as the ln of, well, that's quite a big thing, 4x to the 6th, all to the 3/2, all over this one, so it'd be 2y to the 10th, all to the 4/5. Okay, so I've expressed it as one logarithm. They do say that they want you to simplify, so maybe we should try a little bit of that. I see a 4 here and a 2 there. Love to cancel them, but these exponents here sort of take precedence. So maybe what I'll do is I'll use power of a product here. So I've got a product of 4 times x to the 6th, all to the 3/2. Why don't I raise each of those to the 3/2? So this will be ln. On the top, it'll be 4 to the 3/2 times x. Okay, 6 times 3/2. What's that? 6 times 3 over 2, be 18 over 2 divided is 9. So that's what I get with that top stuff. Over, on the bottom, it'll be 2 to the 4/5. And then y to the 10 times 4/5. What's that? 10 times 4/5. 40 divided by 5 is 8. There. Okay, feeling pretty good. If you'll notice, this is the answer that they have in the back. So I have the x9 and the y8, got those two. But they only have a 2 there, as opposed to I have a 4 and a 2. Well, maybe what I can do, I know that if I'm dividing common bases, I can subtract their exponents. These aren't common bases, but that 4, I can make it a common base. So let's do that. So it'll be ln of, instead of 4, that's 2 squared to the 3/2. Okay? And then I've got x9 all over 2 to the 4/5 and y8. Okay, I'm getting closer. Let's multiply this stuff. So that would just be 2 to the 3rd on the top. So ln of 2 to the 3rd, right? 2 times 3/2, is that right? 2 times 3/2. Yeah, those cancel, 3. x9 all over 2 to the 4/5 y8. So now I've got common bases, these two right here. Notice it's within these brackets. I am taking the logarithm of this, but within the brackets I can do operations. So if I have common bases, I have to subtract their exponents. So 3 take away 4/5. Could do that on my calculator, or I could find a common denominator, which would be 5. Right? 3 is the same as 15 over 5. Subtract these and I get 11 over 5. So I'll have the ln of 2 to the 11 over 5. And then I have x to the 9 I all over y to the 8th. This would be, I think, as simple as I could get. The 2 to the 4/5 or 11/5, maybe there's more that I could do there, but I think that's probably as simple as I would go. Let's see what they got. Well, they got the same thing, 2 to the 11/5. Okay, hopefully that helps you in simplifying that question. That's a nasty combine into one logarithm question.